Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Do you want a cookie, Dr. Tot? Here you go. Welcome to Algebra 1. I apologize for not being able to stream Monday or Tuesday. We had some internet connection problems, but we've resolved them. I will be making a recording for session 2, so then we're back on track for Friday's class. So look out for that recording, but otherwise we're going to get into solving systems of equations. Systems occur in algebra whenever you have more than one mathematical statement, oftentimes written in terms of more than one variable that you're trying to solve. In math, when you have more than one unknown, at least in algebra at least for now, when you have more than one unknown, you need at least as many mathematical statements. You need at least as many equations as you have unknown variables in order to solve for what's called explicitly, which is solve explicitly, which means that you solve for an actual numeric value. Otherwise, there's something called solving implicitly that we'll learn about later, and that's when you solve for one value, one variable in terms of the other, which means you don't get an actual you don't get one answer to the problem. You get an infinite range of answers depending on what input value you put in. That's outside the purview of today's class, but we're going to talk about when we have more than one mathematical statement, how we can solve algebraically for a numeric answer. The overall gist, though, is that you need at least as many equations as you have variables. That's the overall meaning I'm trying to get across. Let me go ahead and share my screen with you. And just a reminder that these are live streams. So there is a little bit of a delay with the iPad, but I'll keep track of that. If there's any questions at any point, feel free to type them into the live chat feed, or if you're watching this recording, you can type them into the comment section below, and I'll get back to you as soon as possible. So just to recap, overarching theme here, a system of equations is a fancy name for when you have more than one equation, usually in terms of the same variables. There are 3 methods of solving a system of equations. 1, graphing, 2, substitution, and 3, the third method has 2 names or goes by 2 names. You can either call it the elimination method or some people call it the addition method, but it's the same concept. So we're going to be going through these 3 methods today. A repeat of what I said before, some background information. You may have more than one variable in a problem, meaning that you have more than one unknown amount that you're solving for. And if you do, you need at least as many equations as you have variables in order to solve explicitly, meaning for an actual finite number, numeric value like 23 or 2.5. If you have more unknowns than you do equations, you cannot, excuse me, that says sol. You cannot solve explicitly, but rather implicitly, meaning your answer will not be a number, but an expression in terms of one or more of the other variables. We're going to get more into that later, so don't worry about the latter end of that, but I just want to make sure that you understand that this system, the idea of the system, relies on the fact that you have at least as many statements as you have unknowns in order for it to be calculable. All the problems that I'm going to present to you are going to be written for that to be the case. You're not going to have to worry about it, but I just want you to understand from a mathematical standpoint, now we're introducing multiple unknowns into these problems, so we're going to need more than one statement in order to evaluate them. If you have any questions, as always, just let me know. To solve using the graphing method. So first, you're going to graph the equations on an x and y axis and look for a point of intersection between all equations. So All of the problems we're going to look at today are only going to involve two equations. But if you had more than two equations, sometimes they can be tricky, and this is particularly true on the SAT and PSAT. They can give you a graph and it has multiple, like more than two equations, and you're looking for a point of intersection, but there's no point in which all three overlap each other or intersect each other. There's only points where only two of the three equations overlap. That's indicative of there not being any solution at all. So you have to make sure that the point includes all of the statements that are relevant to the problem. Here, what you want to do is graph these. So remember, notice that these are linear equations written in y equals mx plus b form. Remember that m here is your slope. That's your change in y divided by your change in x. That little triangle symbol is a mathematical symbol for change in. And remember that your b value is your y-intercept. So in order to graph in this form, it's easiest to start with your y-intercept. So look at the b value. That is definitely a point on the graph. So go to that y value on the y-axis and you can place a point there. And then you can use the slope to determine a second point. So if your slope is 2, then you're going up 2, right 1. If your slope is 3, then you're going up 3, right 1. And you can plot out a few points in order to connect the points together and graph them. So I'll give you 3 minutes. Please look at number 1, and then I'll give you the solution. Okay, so let's look at this. We have two equations, y is equal to 2x plus 1. So looking at that b value of positive 1, I know that 0, comma 1 has to be a point on this equation because it has a y-intercept of 1, and the y-intercept only occurs when x is equal to 0. Excuse me, the y-axis, not y-intercept. It is the y-intercept too, but that's because it's intersecting the y-axis. So the y-axis only occurs when x is equal to 0, so I can plot out that point 0, comma 1. Now this slope of 2, remember that you have to think about this in terms of a fraction. You can rewrite any number, any whole number as a fraction by just putting it over 1. Because if m is equal to 2, or in other words, if m is equal to 2, which is the same thing as 2 over 1, remember that that represents your change in y over your change in x. So I'm going to go up 2 over 1, and that will be a second point on this line. And so I can connect them and sketch out the line as looking something like that. Now the second equation of y is equal to 3x, that's really 3x, 3 over 1 times x. If I wanted to write that slope as a fraction, 3 is the same thing as 3 over 1. And also notice that it doesn't have a b value because the b value is technically 0. So I know that this function, this equation y is equal to 3x, y is equal to 3x, goes through the origin 0, comma 0 because it has a y-intercept of 0. And then it has a slope of positive 3. So I'm going to go up 3 over 1. That's going to give me that same point that I went through for the other equation. And then I can connect them together in a rough sketch to look something like that. And so we can see that these two equations intersect at 1, comma 3. So the solution here is going to be 1, comma 3, which means x is equal to 1 and y is equal to 3. So you have to be able to interpret that coordinate solution point, or that coordinate point that represents the solution set. So 1, comma 3 means that the solution set to this system of equations is x is equal to 1 and y is equal to 3. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. I'd like you to look at the second problem. We have y is equal to 4x minus 2 and y is equal to 3x. Okay, looking at this first equation of y is equal to 4x minus 2, we have a b value of negative 2. So I know that this graph crosses, the first equation crosses the y-axis at negative 2. And then I can think of the slope, it's written as a whole number as just 4, but I can always think of 4 written as a fraction as 4 over 1. So I'm going to go up 4 over 1. So that's going to give me this point right here, which allows me to connect the 2 points together. And so I have an overall graph that would look something like this. Now for y is equal to 3x, this is really 3x plus 0, so this graph intersects, this equation intersects the graph at the origin, 0, 0. And then I can think of the slope as 3 over 1. So I'm going to go up 3 over 1. So notice that's going to give me right here. And then I can go up 3 over 1 again, and that's going to give me this point right here. And actually my other graph, I'm not a great artist, so let me redo my blue line, because actually it's supposed to go right through that point. Not a great straight line again, but I do apologize. There's a reason why I'm a math teacher. So this, if my line were straighter, then this would overlap at these 2 points right here. Excuse me, this 1 point right here that I'll do in light blue, and that's going to be 2, 3. So when x is equal to 2, y is equal to 3, because they overlap or they intersect at the coordinate point 2, 3. Excuse me, not 2, 3, 2, 6. I apologize. So our solution here, x equals 2, y is equal to 6. If you have any questions, then please let me know. Last one, I'll give you 2 minutes, just for time's sake. I want to make sure that we move along to the other 2 methods. So I'll give you 2 minutes. Please look at number 3, and then I'll go through the solution. After 1 minute, I'm going to start to solve just so we can get on to substitution. But 2 minutes, and then I'll give you the solution. Okay, so if we graph these equations out, the first equation, 5x plus 5, we have a y-intercept of positive 5, and then we're increasing by 5 on the y for every 1 we increase on the x. So first of all, I had to adjust the scale of the graph, so I counted by 5s on the y-axis and then 1s on the x-axis, just so I would fit everything in this window or in this view. So I started at 0, 5 for a y-intercept of positive 5, and then I went up 5, right 1. And I did that a few times to trace out a few plots, a few points to connect. Then with the second equation, y is equal to 10x minus 10, we have a y-intercept of negative 10, and then we have a slope of positive 10. So I'm starting at 0, negative 10, and then I'm going to go up 10 on the y every time I go right 1 on the x. So up 10, right 1 gives me 1, 0. Then up 10, right 1 again gives me 2, 10. Right 1, up 10 again gives me 3, 20. So notice that these two graphs overlap or intersect at the point 3, 20. So the solution to this system is x is equal to 3 and y is equal to 20. If you have any questions, then please let me know. Otherwise, let's talk about the substitution method. So you can also solve these equations, or these systems, I should say, using substitution. In order to use the substitution method, you want to isolate one equation for one of its variables. You plug this resulting expression into the other equation for that variable and solve. The answer in this case, when you do the substitution, should be a number. So you get an explicit value as an answer. Then you only have one unknown. So then you can plug that number directly into either of the equations and you can solve for the variable that you originally isolated for. So it's really just isolating one for an expression, plugging into the other one, getting a number, plugging that number back into the original equation and getting the other number, because there's going to be two solutions, or there's going to be two components to the solution, that should be singular. There's going to be two components to the solution because there's two variables. So I'm going to give you 3 minutes. Please look at negative 4x plus y is equal to 2 and negative 6x plus y is equal to negative 2. Okay, so to solve with substitution, we're going to pick one equation and isolate it for one of the variables. Now you want to make your life easy as possible. So if we look at the first equation, notice that it's much easier to isolate for y than it is for x because the x has a coefficient next to it. So if I just add 4x to both sides of this first equation, that'll cancel out the 4x on the left and leave me with the equation y is equal to 4x plus 2. So that means wherever I see y in the second equation, I know what y is equivalent to. Y is equivalent to 4x plus 2. So I'm going to substitute that value into that expression, I should say. I'm going to substitute that expression into the second equation. So I'm going to get negative 6x plus 4x plus 2. Now, I always recommend you putting parentheses around this value that you're inserting. If the operator was subtraction, or were subtraction rather than addition here, you would have to distribute that subtraction sign within the parentheses. So that would make a big difference. But here it's addition, so that doesn't make any a difference because it's the same thing as like positive 1 times 4x and positive 1 times 2, which is not going to have any effect overall. But if it were subtraction, then it would be different. That subtraction sign would have to distribute within the parentheses. It being addition, we can just remove the parentheses and think of this as negative 6x plus 4x plus 2 is equal to negative 2. We can combine like terms with the negative 6x and the positive 4x, which will make a negative 2x. So we have negative 2x plus 2 is equal to negative 2. If I subtract away 2 on both sides, then I'm going to have negative 2x is equal to negative 2 minus 2. Negative 2 minus 2 is negative 4, so that's going to be negative 2x is equal to negative 4. Dividing by negative 2 on both sides, we're going to find that negative x is equal to negative 4 divided by negative 2, which is positive 2. So we know that x is equal to positive 2. Oh, I'm sorry, let me scroll up there. So we just found that x is equal to positive 2. So we can take either of the equations and substitute 2 in for x in order to solve for y. So we have the numeric value for x. I'm going to just take the first equation and say negative 4 times 2 plus y has to be equal to positive 2. So negative 4 times 2 is going to be negative 8. This is going to be negative 8 plus y is equal to 2. If I add 8 to both sides, y is equal to 2 plus 8. So y is equal to 10. So your solution here is x is equal to 2, y is equal to 10, and written as a coordinate point, that would be 2, 10. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please look at number 2. Number 2 asks y minus 2x is equal to 3 and y minus 3x is equal to negative 2. Please solve using substitution. 3 minutes and then I'll give you the solution. Okay, so if we start with the first equation, notice that we can isolate pretty easily for y just by adding 2x to both sides. That'll cancel the 2x on the left. So y is going to be equal to 2x plus 3. So now that we know the value of y, where I see y in the second equation, I can put in what it represents in terms of x, which is 2x plus 3. So I'm going to have, in the second equation, 2x plus 3 in parentheses minus 3x is equal to negative 2. Now I don't have a negative sign outside of the parentheses, in front of the parentheses, I should say. It's behind the parentheses, but that's applying to the 3x. So there's not a negative sign out front of the parentheses, so I can just remove the pair of parentheses and consider this as 2x plus 3 minus 3x is equal to negative 2. Combining like terms, 2x minus 3x is going to be a negative x, so we're going to have 3 minus x is equal to negative 2. Subtracting 3, we're going to find negative x is equal to negative 2 minus 3. Negative 2 minus 3 is going to be a negative 5. So x is equal to negative x is equal to negative 5. I don't want negative x, I want just x. So divide by negative 1 on both sides to find x is equal to positive 5. Now that I know that x is equal to positive 5, I can substitute that into either of the two equations. The last time I chose the first one, so this time I'll choose the second one. I have y minus 3x, so I'm going to have y minus 3 times 5 is equal to negative 2. 3 times 5 is 15, so I'm going to have y minus 15 is equal to negative 2. Adding 15 to both sides is going to give me y is equal to negative 2 plus 15. Negative 2 plus 15 is going to be a positive 13. So x is equal to 5 and y is equal to 13, or a coordinate solution of 5, 13. If you have any questions, then please let me know. We actually won't be able to get to the elimination method today, just looking at time, but I will make sure that we'll start off session 2 with the elimination or addition method. But otherwise, let's look at question number 3, and this will bring us up to the end of the session today. I'll give you 3 minutes, and then we'll go through the solution. Okay, so looking at negative 10x plus y is equal to 15 and y minus 20x is equal to negative 25. So they shifted the position of y and x around, but that's okay. If we just start with the first equation, notice that it's pretty easily isolated for y if we just add 10x to both sides. So that'll cancel the 10x on the left, leaving us with y is equal to 10x plus 15. So when I see a y in the second equation, I can put in 10x plus 15. So that's going to give me, in parentheses, 10x plus 15 minus 20x is equal to negative 25. But again, that negative sign is attached to the 20x, not outside or out front, I should say out front of the 10x plus 15. So I can just remove the parentheses and collect like terms. So negative 20x and a positive 10x will create a negative 10x. So I'm going to have 15 minus 10x is equal to negative 25. If I subtract away 15 on both sides, actually let me do that in another color. So if I subtract away 15 on both sides, negative 25 minus 15 is the same thing as negative 25 plus negative 15, which is going to give me a negative 40. So I'm going to have negative 10x is equal to negative 40. Dividing by negative 10 on both sides, x is going to be equal to positive 4. Excuse me, positive 4. So if x is equal to positive 4, I can sub back into either one of these equations. I'll take the second one. So y minus 20x. So y minus 20 times 4 is equal to 25. Excuse me, negative 25. So negative 20 times 4 is going to be a negative 80. So I'm going to have y minus 80 is equal to negative 25. Adding 80 to both sides, y is going to be equal to negative 25 plus 80. And so y is going to be equal to 55. So the coordinate solution would be 4, 55. If you have any questions on anything that we've done today, then please, please, please let me know in the comment section below. Look out for the recording of session 2 that I'll put out, and then we'll be back on track for Friday's session where we'll finish off this week's topic. If you find these videos helpful, please like and subscribe to the channel. Otherwise, I hope you all have a wonderful night. Dr. Todd, do you want to say goodbye to everybody? Come on, you gotta say goodbye. Come on. Can you say goodbye? You can do it. Say goodbye. Bye. Say bye. Very good. Thank you guys very much. I hope you have a wonderful night, and I'll talk to you all on Friday. Look out for that recording, and have a great night.